topic for this video is ionic bonding. The essential questions are: what is an ionic bond, what are the properties of an ionic bond, and what are the properties of a metallic bond? So an ionic bond is an electrostatic attraction between positive and negative ions. If you think about playing with magnets and how one end attracts really closely to the other end, that's the same type of thing here when we get a positive and negative end. So one example is salt, and that's a picture of salt on the molecular level. It's a salt crystal, and it forms because sodium has a positive charge and chlorine has a negative charge, and they attract together. This is an example of cesium chloride, which is another ionic compound, and then we have calcium fluoride. And those are both pictures showing you a crystal lattice, which is a structure that they form in a crystal, and we'll talk about that a little bit later this video. So to form that bond, the electrons are transferred from a metal atom, which is why the metals become positive, and they're transferred to a nonmetal atom, which is why those become negative. So if I start with a sodium atom and a chlorine atom, the chlorine atom says, hey, I'm looking for an electron, and the sodium says, cool, I happen to have an extra one. And so they pass the electron from the sodium to the chlorine, okay? And when that happens, the sodium becomes positive, and the chlorine becomes negative. And then those opposite charges form an attraction, so they still stick together. Okay, so positives and negatives will be attracted to the other. So for ionic bonding, we involve the transfer. These are only happening with the valence electrons, which is the outermost circle of electrons on the energy level. One atom loses one or more valence electrons to become a cation, which is the positive ion. The other atom gains one or more valence electrons to become an anion, or a negative ion. And these are electrically neutral, which is what we were doing when we did the formulas and we evened out the charges so it made zero. That's what that means, is that they're electrically neutral. It usually results from the bonding of a metal with a nonmetal. For example, our alkali metals, which is our group 1, typically bond with the halogens, which is our group 17, to form an ionic compound commonly referred to as a salt. Now we have our table salt, which is sodium chloride, which is an alkali with a halogen, but there are other types that are also called salts that we don't necessarily consume as table salt. The chemical formula for an ionic compound is referred to as a formula unit and not a molecule. At room temperature, crystals of ionic compounds exist as regular three-dimensional arrangements of cations and anions held together. So this is what I was showing you before. This is called a crystal lattice. So this is a regular, orderly type of arrangement. And here's an example of what the sodium chloride looks like. So you have the chlorine ions and the sodium ions, and they form a structure that's very proportioned and regular. Now let's look at some ionic compound facts and some things that are ionic compounds that you might know about in your house that you may not realize are ionic. First, we should all know about table salt, which is sodium chloride. Another one is sodium bicarbonate or sodium hydrogen carbonate, and that's baking soda. We have sodium hydroxide, which is lye, and it makes soap. Okay, it's not the only component of soap, but it helps make soap, and it's a common base. Sodium hypochlorite is bleach. Calcium hypochlorite is what is used for your pool chlorine. Magnesium sulfate is Epsom salt, which you might use in the bathtub. Calcium carbonate is used in chalk and marble and limestone, and it's also used as a main component of Tums. Calcium sulfate is used in plaster of Paris. Some properties of ionic compounds, which again sometimes we just call ionic compound salts, are that they are made up of a metal with a nonmetal. So we take our metals on the left and combine it with our nonmetals, which are on the right of the staircase. It's a solid crystalline structure. Okay, those are all crystals and all examples of salts or ionic compounds. They typically have a high melting point. They're soluble in water, which means they'll dissolve. They are hard or brittle, but they're not malleable. If you hammer them, they're going to break apart. They're not going to hammer out into a sheet like a metal would. They conduct electricity, but only if they're melted or dissolved. So they have to be in some form of liquid, whether it's a solution with water or whether it's just melted into a liquid itself. They can't do it just as a solid. And if they are a solid, they're a non-conductor. Okay, now we're going to talk about bonding in plain metals. Metals are malleable, ductile, shiny, and good conductors. They're malleable, which means they can be hammered out into a sheet. They're ductile, which means they can be drawn into a wire. And it's because of the metallic bond. And this is kind of how it works. The gray circles represent the atoms, and the red circles represent electrons. And so they're just kind of allowing the electrons to go wherever they want within this framework of metallic bonds. So you have metal ions in a sea of electrons.